Okay, we're going to do metric conversions, but more importantly, we're going to learn a way to solve problems using our units. And this is called factor label problem solving. Now, before you get started, I want you to understand I am teaching you how to do factor label. And that's what I want you to understand. We're going to use it to do metric conversions. And I know some of you do understand metric conversions and you can move your decimal point. But what I really want you to understand from this is how to solve problems using factor label. This is what I will be testing you on. This is the main goal of this presentation. We're just using metric conversions because that's something you're going to have to also do. So these are the conversion factors you need to know. And these first ones here you're going to be familiar with. What you might not be familiar with is 1 meter is 10 to the 6 micrometers. And let me get a pen here. The symbol for micro is this. It's a Greek letter of the alphabet mu. So when you see this, that's a micrometer. And then there's 1 million micrometers in a meter. There's 1 billion, 10 to the 9th nanometers in a meter. These are the ones that you may not be familiar with. Okay, so let's start off by doing a simple problem. And I asked you how many nanometers are in 0.01 meters. In factor label, the first step is to write down what you're given. In this case, you're given 0.01 meters. So right here. 0.01 meters. In step 2, you're going to multiply, see right here, by the conversion factor so that the unit you are looking for is on top. Now you want your answer to be in nanometers, so I put nanometers on top. I put meters on the bottom so that the meters cancel out. Whatever you want to cancel out goes on the bottom. What you're looking for, the unit you're looking for, is on the top. And that's the essence of factor label. So this we call a conversion factor, where you go from one unit to another. And then you are going to work it out here. If you need to do another unit conversion, then you can do it, and you can do 3 or 4 or 5 or 6 or how many you want. Okay. So now, and look, I told you to multiply. Sometimes you want to put equal signs, but equal means it's like a proportionality, and it's not. This is a conversion factor, so you do times. So you put 0.01 meters times 10 to the 9th nanometers, divided by 1 meter. The meters cancel out, so you get 10 to the 7th meters. There's your answer. Okay, harder problem. A little bit harder because this is a 2-step problem. By 2 steps, I mean you do 2 conversion factors. So step 1, you write down what you're given. Step 2, multiply by your conversion factor. You want to get rid of millimeters, so that goes on the bottom here. So it cancels this out. You want meters, and your conversion is 1 meter is 1,000 meters. This is why you have to know those metric units I showed you on the first slide. Now this gives you meters though, and the question says you want to go to kilometers. Okay, so now we have to get rid of meters, so I multiply again by another conversion factor. Okay, meters is on the bottom, kilometers is on top. The equivalency is 1 kilometer is 1,000 meters. And so then what I do is once my units are all squared away, I just go through and either multiply or divide. So here I'm doing 17.01, and I have to divide, I know that's a funny divide sign, by 1,000 because 1,000 is on the bottom, and then I divide again by another 1,000 because this 1,000 is also on the bottom. This 1,000 is on the bottom there, so that's why I divide it. And I get 1.701 times 10 to the negative 2 kilometers. All right, now here's one that really makes sure you understand this factor label method of problem solving. And I might add that you can expect to see something like this on your test. So the background is I tell you what all these conversion factors are. 1 Zot is 10 clots, 1 clot is 15 durs, 1 dur is 10 Voss, 1 Voss is 2 Futs. And my question is right here, how many Futs are in 2.13 Zots? So step 1, write down what's given. Step 2, multiply by my first conversion factor. I put Zot on the bottom to cancel it out. And I know 1 Zot is 10 clots, so I put 10 clots on there. Now I don't want my answer in clots, I want it in Futs. So now I've got to cancel out clots. So here's my second conversion factor. Clots is on the bottom, so it cancels out. Then I got to get rid of durs. Here's my third conversion factor. Durs is on the bottom to cancel out. Now I have Voss. And then my last conversion factor, Voss is on the bottom, and I get Futs. And this is the unit I am looking for. So I actually went through 1, 2, 3, 4 conversion factors here. Now, to do the math, I just go 2.1 times 10 here, times 15 here, times 10 again here, then times 2, and then of course it's all divided by 1. So it comes out to be 6,390 Futs. All right, let's go through a few questions. If you're in class, I'll probably ask you to answer these on your cell phones, but if you're watching this at home, you're not going to be able to do that. So I want you to answer it, pause the video and answer it, and then I'll turn it on again and I'll tell you the answer. So this is one of the basic facts you need to know, and there's a million. Million micrometers in a meter. Remember, the symbol for micro is this. It's kind of a funny shaped U from the Greek letter of the alphabet. Question 2, when factor label problem solving, what unit do you put on the bottom of your conversion factor? Okay, so your conversion factor is your equivalency. Pause. All right, now start it again. And on the bottom should be the unit you want to cancel. Okay. Now let's work out a little problem here. How many centimeters are in 2.13 times 10 to the 11th meters? So you're going to convert this to centimeters. So go ahead and set it up using factor label. Pause. All right, you're back with me. You have your 2.13 times 10 to the 11th meters. You want meters on the bottom. Notice I always put my units first, centimeters on the top. Then this is where you have to be a little careful. You just have to say, well, what's the equivalency? Well, there's 100 centimeters in 1 meter. I show my units cancel out. Now I go 2.13 times 10 to the 11th times 100 will give me 2.13 times 10 to the 13th centimeters. So the answer is B, right here. Okay, now this is another problem, and I will tell you it's a two-step problem in that you have to do 2 conversion factors. You probably want to go from kilometers to meters first, and then from meters to nanometers. So pause it, work it out. All right, you're back with me. So 0.032 kilometers. Now watch how easy you can start doing these once you understand it. See, I just set it up so that my units cancel out. I'm going to convert this to meters first, and there's 1,000 meters in a kilometer. And then, okay, my kilometers have canceled out. And then I want to get rid of my meters, so that goes on the bottom. And I want nanometers. There's 1 billion nanometers, or 10 to the 9th nanometers in 1 meter. Meters have canceled out. Now I just do my math, which is 0.032, that's a point, times 1,000, which is 10 to the 3, then times 10 to the 9th. And when I work that out on my calculator, I'm going to get 10 times 10 to the 10th nanometers. So the answer is none of the above. All right, so that's it for factor label. I hope you answered everything correctly.